Hello everyone, welcome back to my channel. Hope you all are doing good. Before moving ahead, as we are going to complete our data science journey in some time, I would request every one of you to join hand with me in just help me by subscribing to this channel if you really like the content, because I'm putting a lot of effort to make concepts understandable to you, to make things in front of you. I'm not leaving any single concepts. I'm putting a lot of effort there. So your support, your subscriptions, or your small step towards me is going to help me a lot to make really good contents. As we are going to close with our data science, we are going to start with a machine learning, and those are really advanced concepts to know. And I'm going to make your learning very easier, so that you just need to go through these videos and you can go and crack your interviews. And this is all I need. I just need your time. You need to invest your time, and you need to learn, and we all will learn and grow. As a person who have almost 15 years of experience in IT industries, I am putting a lot of effort just to make you people understand. So today's topic, we will discuss about outlier detection using MAD technology or MAD technique. That is nothing but median absolute deviation. And we will start without delay. Let us talk about our topic. So we understood about zscore method, we understood about IQR method. Now we will talk about MAD, mean absolute deviations. So what exactly is mean absolute deviations? Like in each outlier detection, right, we have few techniques. In zscore, we understood that we have to take each data points, we have to get a difference with mean, then after that we have to divide that with standard deviation. So their mean and standard deviation came into picture. In IQR or interquartile range, we are getting the median value of it, or the one which is there in the box plot, the complete thing, like with whisker and all. So we got the median value, we got which is Q2, then we understood Q1 which is my 25 percentile, we understood Q3 which is my 75 percentile. We got the difference, that difference is nothing but our IQR. Then we got the lower limit and the upper limit. The lower limit is Q1 minus 1.5 into IQR. The upper limit is Q3 in plus 1.5 into IQR. And whatever the values are coming in between, those are our valid data points. If those values are coming beyond those two lower and upper bounds, we are considering them as an outlier. In this technique, we are using the median and the absolute deviation, like the absolute differences between those medians. We are going to take them and we are going to tell, okay, these are your outliers. So let us understand the technique first before moving ahead. So first we have to calculate the median of the data set. Then we have to find the absolute differences between each data point and the median. So we have a data set, right? A data set is containing thousands of values. So each point or each value are your data points. Here I have taken one example just to give you a brief idea on what exactly we are going to do in our below concept or below data frame or the data set. So we have taken one small data set where I have 5 values. We have 2, 2, 3, 4, 5. So median is what, guys? It's a middle point, right? Median is a middle point. If it is a odd, it is going to be the midpoint. If it is even, we have to add, like divided by 2, n plus 1, and we have to get we have to get 2 values over there. So what we are doing, first we are going to get the median. My median here is 3. Okay, then calculate the absolute deviations from the median. Absolute deviations is nothing but, we are like, this is your symbol, right? Absolute. We calculated absolute in zscore. What is that? That is nothing but it is going to make your that difference positive. There won't be any negative value in the data set. That is the meaning of absolute deviation. So I am dividing each data point with my median value. You can see 2 minus 3 equal to 1, 2 minus 3 equal to 1, 3 minus 3 equal to 0, 4 minus 3 equal to 1, 14 minus 3 equal to 11. So I got the absolute deviations are 1, 1, 0, 1 and 11. Then after that, again I have to get we have to reorder, because if I'll get the median, then what it is going to be? It is going to be 0, right? It's incorrect. So we have to reorder whatever the deviations we got, and it is going to take care. Like, you don't have to do it explicitly. It is going to take care by default. Then after that, you have to take the absolute deviations, or the median of those absolute deviations. So here we have 1. So I can say that the MAD, or the mean absolute deviation for this data set, is 1. Now let us understand with our Titanic data set the same thing, because Titanic data set is a standard I am considering here, because it has so many missing values. And let me run this first. So these are our libraries, right guys? We have pandas, numpy, then matplotlib, pyplot, cbond, and I have taken scipy.stats. That is containing your median absolute deviation. So this is your library, or this is a module, median underscore abs underscore deviations. With this, we can achieve our, we can detect our outliers, and let us see how to do that. So what is the first step? The first step is what, guys? We have to collect our data, right? So we did that. We have collected our data by using data.head or data.tail. Then what is the next step? We need to know the info of that data. What exactly, what are the data types present in that data set? Then what are do we have any null values or not? So all those things we can get it from data.info. And I can clearly see that I have age column, or the age feature is having 714 counts. However, this is non-null, but still we have null values in this data set. We have null values in this data set. And you can see how to detect it. If you'll read this completely, it is going to be easier. And few people have asked me, they are facing difficulty in understanding in data cleaning. So I'll tell you one simple idea. So the first line, what it contains, guys, it contains the range or the index. Indexes are nothing but a total number of rows present in your data set. So I have total 891 rows present in my data set. However, my index starts with 0 and it ends with 890. So we are clear from this line, this line, that I have 891 entries. That means what, guys? Each and every row should be present, and it should be 891 in total. However, if we'll come down, and if we'll, it broke down the columns or the complete data set based on their columns. So I am seeing that I have total 15 columns present here. And how to understand how many rows are present in each? This is the first line, right? I have survived column. So I have 891 entries. That means it is not containing any null values. If my total, or the total rows present in that column, is equal to the range index or the entries present, that means our data set is not containing, or that particular column is not containing any null. Similarly, we have P class. In P class, we can see 891. It is not containing any null. Gender, it is not containing any null, right? Age. When we are coming back to age, we can see that it is just containing 740. It is not containing 891. That means the rest all are present as a NaN in your dataset, not a number, right? Then SIB-SP. It is 891 present. Then Parch 891. It does not contain anything. Then Embarked, I can see there are few. It is not much, but there are few. 889. Then DEC. You can see DEC. It is containing heavy NaN numbers or heavy null values, because it just contains 203 data points in that particular column. Then Embark Town, again it is containing null values. So this is how you can detect your null values by info method. By your info method. Then as we knew that, okay, my age is containing null values, what is the next step, guys? We have to understand how many null or just from here whatever we saw, we can get that programmatically, and there are two ways how to get it. One is you can use each null value, and we have understood this from data cleaning method or the data cleaning concept. So you can take your column data age, and I'm telling, okay, each null, if this age containing null values or not, values dot any. If I'll use this, then it is saying me that, okay, I have, that means true. True means it is containing null values. If the output will come false, then it is not containing any null values. Second method is you need to take each NA. That means we have two methods, right? One is each null and one is each NA. If I'm taking each NA and I want to get sum, I will get whole, like this one column you will get one information. It is containing like wherever you have null values, it is going to give you numbers. Wherever it is not containing any null values, it is going to give you zeros. However, I do not want to see my zeros. That's why I did Boolean indexing, and Boolean indexing I have already explained you. Very important concept in case of data. So what I did, the same thing I have taken, and I am telling my data set should contain only the values which have greater than 0. And I am getting, see, age I am getting 117. Embarked I am getting 2. Then deck I am getting 688. Embarked down I am getting 2. So it is clearly visible that, okay, I have 177 null values present in my data set. And these are different ways to know whether you have null values present in your data set or not. Now, what is the next step? Once we get our null values, we need to treat those null values. We need to fill them, right? Otherwise, you cannot give that as an input to your machine. Understood, right? Now, we will fill our age. As age is a numeric column, we can get the mean of it and we can fill it out. And I have taken that step directly. I have taken data.age, data age, fill NA. Fill NA is a method, right? We understood in our data cleaning concept. And I am getting my mean of that, and I am filling wherever the empty values are present with mean. And this is what I am getting. And it's filled now. If I am running, it is filled. Now, if I'll come back and see it is giving me false, that means it does not contain any null values anymore. Similarly here, I am not able to see age anymore, correct? Now, we will come back and we will understand how to detect outliers if it is present in my data or my age column or not. So, first thing is what, guys? We have to get, we have to assign with some, like I'm taking age, right? So I cannot give the complete input, like I cannot give my data. So I can take data age. That means I'm telling I have to take my age, and on that age I am getting my mean absolute deviation. Then first step is what, guys? I need to get my median value. And how to get it? We have NumPy method for that, right? np.mean, np.median, these are the methods. So np.median I have taken, and I am passing my value or passing my series. Next is what? We have to get the absolute deviations. Absolute deviations, how can we get it? We can get by, we will take each and every data point and we have to get the difference with the median value, right? And we have to get the absolute value of it. Like we are not going to get any negative value. All we will get is a positive value. That's why I have taken np.abs. np.abs is going to park, or it is going to cancel your negative value if it is going to be there at all in your data set. So I got my absolute deviations. Now what is the next step, guys? we have to again get the median of whatever the absolute deviations we got. We have to get the median value of it, right? So I got my MAD value or the mean absolute deviation value, the final one. Next, what is the step, guys? Here there are few theories present. So a more robust MAD using SciPy's function. Okay, we did that. Then we have, define, like we need to define a threshold, right? And we saw that most of the times the threshold is either 3, right? 3, because we are considering our standard deviation, 3 as a standard deviation. So we have taken out threshold multiplier as 3 here, right? Then after that, we are calculating lower bound and upper bound. Lower bound is what? We are going to take our median value. Then after that, we are multiply, like the threshold, we are multiplying with MAD value. Then upper bound is we are adding it. So like that, we are going to get a lower bound and upper bound. And outliers, how can we get? We have to take. So we will get our outliers by taking that. What is this, guys? This is your data set, right? This is your age. So I am telling, okay, if my age is less than lower bound or if my age is greater than upper bound, consider everything as an outlier and it is going to give me a series of data. Then I'm printing everything here. I'm getting my column, I'm getting my median, I'm getting my mean absolute deviation, I'm getting my lower bound, my upper bound, and I'm getting my identified outliers. Now, if you'll see this output, right? So this is your column or this is your whole ages, right? Till 890 index or 891 columns. Then I'm telling, okay, my age, like my name of the column is age, length is this, data type is float. Median value I'm getting 29.7 out of that. Then MAD or the mean absolute deviation I'm getting 6.30. Lower bound I'm getting 10.80. Upper bound I'm getting 48.60. And with this method we got this is our original shape 891. After removing data frame, after removing outliers, I'm getting 747. That means almost 120 or 30 rows it has removed. Okay. So, this is what, or this is how our like mean absolute deviation is going to be calculated or over a data set. However, you can get the same thing like median ABS deviation. You can just put data, then you can just apply scale. This is another method. So here I have taken this, right, this SciPy dot stats import median absolute deviation. So here we can get directly your MAD value by using this. This is just one step. So here we have taken 2 steps, right? If you use this method, MAD value robust, you will just get it by, directly you will get the MAD value like this and you can just use it. That's it. However, you need to know how you are calculating it, right? That is the, best method. This I have taken. You can just try it out, but this is again by using inbuilt function. You need to know how you are calculating, right? Let me take it out and just I don't have to take it out. Actually, it's I have commented it out. You just need to do like this and you can run it. And instead of data, I'm just keeping my where is it? I'm just keeping my age underscore MAD and that's it. It should give me the MAD value or the mean absolute deviation, right? You can just try it out. It is always like it is always going to, you will feel good by, investing by using the inbuilt methods or functionalities. But you need to understand the core concept behind it, why it is happening, right? And this is how you can get it. And I am seeing my outliers. Okay, my outliers dot head. I have almost 747 now in that. Not 747. How many count it is present in my outliers? I think almost 100 and okay, I'll just print like this outliers. How many I'm getting? 144 rows I'm getting. 144 rows I'm getting as outlier. And I'm getting the age underscore man head. Okay. Then what I want to put my box plot. Okay. Now what we did, we took our data or the age and we have removed the outliers, right? And almost 144 outliers have been removed. Now we will see, are those the correct values by using this box plot. So I have taken a box plot just for your understanding, and we can relate it. So you can see your this is your mean line or the middle point. This is your mean line, guys. This is not your this is your median line. My bad. This is your median line, and this middle one, like this point, is going to be your mean point. Okay. So this is your median line. Median line is coming almost 28 to 29, right? So that is correct. Correctly, it is coming correct. So that median line again, we have, where is it? Yeah, we have 29.7, which we are getting correctly. Then next is what, guys? We have 144 outliers, and what are the values exactly present? How those ranges are coming up? So you can see almost 51, 74, 55, 58, 54. All these values, it is pointing out towards outliers. Can we see that in our graph? Yes, we can see. So you can see that after 50, this is what going to do. After 54, almost 54, all these values it is telling or it is giving me is a round shaped, points, and these values are your outliers according to this graph, and the same thing we got there in your data set. And even we are able to see few points below also. So can we just observe that from that thing, from the outliers? Yes, we can see that. Okay, we have values 2, 4, 9, 4. So we have these values also. So you can see this is coming, I think, yeah, this is almost 4 or 5, and below that we are getting outliers. So you observe one thing, guys. We have taken mean of it, right? Mean value, and we have filled it up. Even though we have filled it up with mean value, we are getting so much of deviations or so much of outliers. And it is up to you, like how you are going to treat these outliers, right? Because you cannot remove every time. We need to treat them. What are the basic steps to treat them? We have to make all these points towards this, right? That is how we are, like, let me go to the whiteboard so I can explain you better. So this is your box plot. Let me just take a box. This is your box plot. This is your median line. Mean always is going to be a point there. Okay, and this is your whisker. This is your whisker. These are your outliers. These are your outliers. So when we are saying that we have to treat them, we cannot directly remove them every time. That is not a good practice because it is going to disturb your data set. We need to treat them. We can do that. What we have to do, we have again several methods we will understand in our upcoming videos, but I can say you that concept that these whole things needs to come and fall in this particular range, even this one. Then we can say that, okay, my data is normalized, right? My data is normalized. There is no outliers. This is a very good data, I can say. So how to do that? We have several steps. We can, standardize them. by putting some scaling, or if we'll put scaling, right, it's going to make everything almost near to this, or the range will be less, right? Here, consider that if you have 50, here it is 120, there are almost 70 difference between them, right? If you scale them, all those points or all those value differences are going to be between 0.5 to 2, which is a really good difference, and those cannot be treated as outliers, right, at the same time. So we understood our scaling concept. We can use min, max scalar, standard scalar, or normal general scaling. So we have seen that. And there are so many other methods to treat particularly these outliers. Like you can apply a logarithmic method, or you can just apply square root method. You can, apply, inverse principle. So all those things we will understand in our how to treat your outliers. But you just understand the concept. You cannot always remove it. Yeah, if there are less points, then you can remove it. But if there are more, you can always make and put and fall in this range. Okay. So we understood our mean absolute deviation concepts, guys. And this is again another technique to detect outliers. And yeah, box plot is the best method to detect outliers. But again, it is bit clumsy to consider if you have very large data set. These are different methods. If you have large data set, these are the different methods you can apply, and you can get it. You can brainstorm yourself while practicing. So we'll meet in our next video. Thank you. Well, that would be all for now. We will cover further topics in our upcoming videos. Till that time, see you. Thank you so much, and please start subscribing, like, share your comments, share your feedback, share this channel link to all your friends who are in need to know this AI and ML, because AI and ML is very talk of the town right now, and everyone should learn, to survive in the industry, to go ahead or to move ahead to the future. So, thank you so much till this time or till this point, and I need all your support in future as well. Thank you so much.